Hey everybody, it's Grant Sims here. You can follow me at Chief River. Today we're going to be talking about OAuth for the enterprise and specifically the why, setting the stage for, what can OAuth do for us and how can that enable central identities for systems and developers across the enterprise. A lot of the talks out there on OAuth I feel like are focused on when the components of authorization and authentication are with different parties. So, for instance, the typical kind of banking application where you, as the resource owner, might want to give access to a third party client, a third party application to reach into your bank accounts, maybe with some limited access, pull that information back and aggregate it for you. So, in that case, the parties are split. But really, here, I'm talking about it in the enterprise case where we own the identities, we own the authorization server, we own the clients, we own the resources, etc. So in that case, I still think there's a lot of benefits, but I think it's clouded by the typical OAuth presentations out there, and hence why I wanted to put this together. So today's issues: why do we need central identity, and how can OAuth enable that for us in the enterprise? So typical things, we face today when we don't have central identities for our services and for our development processes. Platform teams handling secrets. Typically, when you want to do an integration with a resource that's on a platform, you're working with these various teams that are, responsible for crafting identities and corresponding secrets. Developers possessing system credentials. It's very common when we are used to static credentials that are crafted on a platform or on a resource, that we have developers possessing those credentials when they were really intended for a system. Key and secret sprawl. As we move to a microservice architecture, distributed architecture, we have lots of little services doing very specific things. And with that, each one needs, to have some authentication or some identity to do those integrations. And when we're in a distributed fashion and we don't have central identities, we see that each one of those integrations typically requires some type of identity and corresponding secret. So the problem gets larger and larger as we, incorporate more microservice architectures. Identity and governance everywhere. So we just talked about platform, multiple platform teams handling secrets, developers possessing the system credentials, lots more of those, ID and secrets or API key and secrets. It becomes a full-time job to try and govern those identities. Long-lived secrets. When we have static credentials that are spread across various platforms, those secrets are hard to rotate and tend to live on much longer than we would like. Sometimes 6 months, sometimes a year, sometimes they never get rotated. Public endpoints. We couple all this with the fact that we are no longer living inside of the internal network or inside of firewalls in our organizations. Our enterprise typically now are integrating with many public endpoints. We're using the internet like the internal network of the past. So let's deep dive into each one of these concepts and giving a little bit more detail. Platform teams handling secrets. Well, how many platforms do you have? You might have an API gateway, a messaging bus system, a data warehouse, a microservice runtime environment. As we sprawl with those, in each one of those, we're relying on them to be part of the process of crafting identities and secrets. It becomes a riskier scenario. We've now, given this responsibility to multiple platform teams. And, we might have policies on, what those secrets look like, how long they live, what the length of them are, what the randomness of them are. And each one of these platforms might have their own technical limitations or abilities to enforce those. Then we have the problem of delivery. Since it's a distributed process now across multiple platforms of, crafting secrets, crafting identities, we also have given the responsibility to those various platform teams to deliver those credentials. Some might send them in a Teams or Slack communication. Some might send an email. They might put the user identifier and the credential in the same email. They might encrypt it. They might not. regardless, we're talking about managing many processes for how we actually get the secrets crafted and delivered to the people, the developers, or the systems that require them. We're relying on humans here. The more humans are involved and the more groups of humans that are involved, the more risk we're putting on these processes. Developers possessing system credentials. When we have a static credential, I'm sure we're all have seen it in the workplace in the past, where you craft an API key in secret. Someone says, "Hey, does anyone have that integration identity in secret?" "Oh yeah, here I have it." Write it on a note, pass it in a Teams message. Where did those credentials go? They're static. They're not attributable to a person. So they typically get passed around. They're stored in environment variables in Postman collections. They're stored in documentation. They're sent in email and Slack, all these different places and mediums where they're persisted for someone to eventually find and try and use. So that comes to who is using them. If you have a security incident or some alerts going on where, hey, this client ID seems to be really hitting our resource hard, who's doing that? Well, we just talked about they're stored in multiple places. They're passed through multiple people. People have knowledge of these. You can't really say who's using it. We can just see that this ID and secret's being used, but we don't really know who's possessing it at that time. So we've lost attribution. Once again, relying on more humans to craft, store, use, and protect those secrets. Key and secret sprawl. Like I said, we're moving to, microservice architectures are here to stay. It's a proven architecture. But with that, we're just going to need more secrets if we continue with this static credential and these credentials that are required on a per integration perspective. So, integration one, hey, I need to connect to this messaging bus system. Can I get a API key and secret from our messaging bus? Then you need to integrate with a couple other microservices or an API gateway. So you get an identity and a corresponding secret from that platform team for each one of those. And then we got to store all these. So we have lots of secrets now, on a per integration basis. They're static. We got to vault them. And that becomes a difficult thing because we have so many secrets. And typically our vaulting solutions are licensed based on how many secrets. And at the end of the day, the more secrets we have to manage, the more risk involved. Identity and governance everywhere. So we just talked about we have multiple platforms, multiple places where these are living, different technical constraints, but how do we answer simple questions? Like, how many static credentials do we have? Well, you might need to reach out to each platform team. Maybe they can run you a report. Maybe they can provide you yet another API to try and pull this information out so you can run some script against it. Regardless, we've made this a very difficult question to answer. And then, we have policies that say, these must be rotated every X amount of days. Well, how old are all these secrets? Once again, we're running manual reports if that data is even available in these platforms. We're trying to write some custom scripts. And then let's talk about when it actually comes down to a security incident or just trying to follow the policy of rotating a credential. We have service A. It's got 50 different, integrations. So it's got 50 different client ID and secrets that we need to rotate. If you want to rotate the credentials for that one service, you have to, orchestrate a process across multiple platforms, multiple platform teams to, update the identity in that platform and then update, the corresponding authentication parameters in the vault or in the config file of, that service. And it becomes very difficult, and why credentials rarely get rotated when we're in this, distributed, non-centralized identity perspective from a service. Once again, we're working with multiple teams. It's that orchestration that makes it very difficult in ensuring that everything goes. And once again, we want to keep these services up. Just because we rotate credentials, we don't want to put ourselves at risk for, availability issues. Long-lived secrets in the public internet. Like I said, it's difficult to rotate those credentials for the reasons I just spoke about. They typically live for a long time in this use case, and the longer the lifetime, the more possibilities for exposure, the more possibilities for compromise. And when you couple that with, we're using a lot of public endpoints today. Once again, we're using the internet as the internal network of the past. And when you combine all of these things together with public endpoints, that really makes for a risky scenario. It's never just one thing that really introduces, a ton of risk to your company. It's a chain of events. Typically, they talk a lot about this, like with a plane crash. You never hear about a plane crashing because of one fault or one error. It's typically a chain of events or a chain of failures that happens that causes the crash. So if you take any one of these aspects that I spoke about, I don't think there's a significant amount of risk in any one individual concept, but when you chain those together, it can become a very risky scenario, and that could ultimately be our plane crash or ultimately be, our compromise in our enterprise. So I ask you, can you relate to these different concepts, and have you seen these in your environment? And if so, I think we have the solve here. We want to get to central identity for our services. Let's make, cut down on these processes, cut down on the people who have to manage the secrets, cut down on the lifetimes of these secrets, etc. And with centralized identity, we can achieve this, and OAuth is going to enable that for us in a standard way. We've done this for our users, and I think it's just a maturity thing that I'm seeing in organizations where, typically when you go to an organization today, you get hired on, you get a single identity, and with that identity, you then get authorized to the various platforms, to your documentation, to your email, to your chat, etc. We just need to progress that and do it for our services and our development process as well. And central identity, we have the Lego blocks, we have the components to do it. It can be muddied by the complexities. And like I said, I think it was muddied also by the fact of the standard OAuth examples. But it's here for the enterprise, and we need to embrace it. Please follow this mini-series as we deep dive into the how and into the technical bits of how we actually get there with central identity so that you can become an expert and so that you can embrace this and reap the benefits of implementing it within your organization. Follow me at Chief River. If you have any questions, please reach out via email, via commenting, via LinkedIn. Also check out my GitHub repo at Chief River, where you can find some demos and some POC environments to really get your hands dirty into central identity in OAuth. Thank you so much and have a great day.